Hello, global supply chainers, and welcome to the third Hangout event in SC1x. Today, we are going to talk about news vendor. As you know, news vendor model is a trade-off between overstacking and understacking, and has a history of more than 130 years. And but this model is still fresh in academia. And last year, Decision Science Journal published a full issue on novel advances in applications of news vendor models. So it's still fresh. And the news vendor model is also commonly used in industry. And now I'm going to ask Dr. Chris Caplice to talk a little bit more about the applications of news vendor in industry.
Sure. Yeah, so we started 2 weeks ago talking about inventory, and we started with EOQ, which is the most widely used model out there. It's why you'll see it even in next week when we introduce SQ, or do they have those now? Are they in SQ? Okay. So you're seeing where it fits in even with those models. Newsboy makes sense, and it's used equally widely for any case where there's a variability either in demand or supply, where you have the cases of either shortage or excess. And so what I find in practice, it's always helpful to try to get an understanding for someone how important stocking out is versus having too much. And so that's why this critical ratio, which you've gone into, hopefully you understand now, the critical ratio is simply the amount of the probability distribution of demand you want to cover. That's all that it's saying. And we find that by doing the ratio of the cost of being short divided by the cost of short plus the cost of excess. So what that does is tells you how much of the demand to cover. And so 1 minus that is my probability of stocking out. So you're starting to see how everything kind of fits together. And so it's always very helpful to ask someone, and I do this all the time, just to ask them how important is it to stock out, the cost of you stocking out versus having too much. Is it a 1 in 10? Is it whatever it is? And then later on, we'll start talking about cycle service level. And that's simply the probability that you won't stock out within a replenishment cycle. And they're very related. So if I tell you your cycle service level is 90%, that's simply saying I have a 10% chance of probability of stocking out. Therefore, my critical ratio is essentially 0.9. And so that's also telling me what my ratio of shortage versus excess is. So they all kind of relate to the same thing, because all you're doing in any inventory model when there's probability is how much of the demand do I cover. And so one of the things that screws people up that I found, students, is when you can apply the news vendor when there isn't a revenue. Because in the example that we used in the lectures, we looked at the revenue of the football jerseys minus the cost, and everything works out fine. And people get really comfortable doing that and using the normal distribution. The world isn't always that clear. So let me give you an example that comes up all the time, and this is in transportation. I'm going to try my new handy whiteboard. So you let me know where I need to go for this. So here's the situation. There's many types of transportation, but the one I want to talk about is the idea of dedicated versus spot. And so think of it this way. I'm running a distribution center, all right? And I can reserve transportation for $1,000 a load, and that's my dedicated. The problem is, however I specify that show up, they will show up, and I have to pay them whether I use them or not. And then I've got this spot market, and this costs a lot more, about $3,000 per load. And if I look at that, the $3,000 per load, it'll always be there. But it costs more. And so the question is, how much dedicated do I want to buy ahead of time? And this happens all the time in contracts, because what you're doing is you're dedicating and buying a fixed amount, and then you've also got the opportunity to buy things on the spot. And so let's just assume for fun that we have a uniform distribution, 50 to 150 loads, and call this a month. And this might be something where you're specifying the number of trucks that you'll have there, and you can usually only change that once a month. So anytime you have to make a decision ahead of time, there's probability of you don't know what's going to happen, and you can't correct midstream, it's a news vendor problem. So you look at this, and a lot of times students will go, well, there's no revenue. So how can I find out what my lost margin is? And so the best way to do this, and I'm going to take it down because we're trying to see how this works. We're trying this out for the first time. So I want to do my cost of shortage and my cost of excess. Some people say underage, overage. I always get them confused, to be honest. So I think of cost of shortage, I'm short. The demand was greater than what I had. What would that be in this case? if I'm short? Well, if I don't have enough dedicated and more loads show up that I have to move, what's my cost? It's the spot. So that's just simply going to be the $3,000. The cost of excess, if I have too many trucks sitting around and not enough loads, how much is that costing me per load? Because these all have to be linear per unit, and that's $1,000. So I'm just going to do some clever math here. Critical ratio is going to be equal to 3,000 over 4,000 equals 0.75. So what does that mean? So I have 0.75. That means 75% of the demand should be covered to find the lowest cost or highest profitability, but same thing in this case. And so that would be, since I'm going from 50 to 150 uniform, that would be 125. So in this case, I would say, let's see if I can make this, 125 trucks. Let's see, which way is best? Probably like that, right? All right, so this is a simple way of doing it. All we did was do cost of shortage, cost of excess. And then you take the critical ratio and find out what it is. It's very, very simple to do. And I just want to make sure you guys realize that sometimes, you don't need to have a profit function necessarily. Just think of the shortage and the excess. I use this whenever I estimate really back of the envelope trying for any kind of contract, how many dedicated units to use. I use this whenever I do any consulting. Let me give you another one that was based on a project that we did here, and that's with promotions. So let me draw something real quick. So if I draw up here, this is time, right? And so here's sales, what normally happen. And then what happens, yeah, you don't want to miss this. Come on. I have this promotion period. And what typically happens in promotions is if this is how much I'm selling, my inventory, I want to pump a bunch of inventory there. And then over the course of the promotion, I should have higher sales and my inventory will go down. And three things could happen. Option one is I don't sell enough and I'm way up here because my expected normal demand is down here. Option two, I stock out. And option three, I end right up where I need to. So the question is, I've got these cases where I want to make sure I have enough product for my promotion. And so think of this as a manufacturer working with a retailer. We did a large project with this about a year and a half ago. And the question the retailer had, there are many other aspects to it, but the simple question was, how much should I plan on ordering for this promotion? Because they order to their DC and then they have to get it out to their stores. Promotions only last 1 week. It takes about 3 days to get something from the DC into the stores and another 3 or 4 days really planning off cycle to get it from the plant. So within the 1 week period, there's no recovery time. So it's a news vendor. They need to decide how much to order ahead of time. They're not quite sure what the demand is going to be. And so they were trying to figure out how much inventory to allocate.
Question regarding the promotion. It's not predictable for them?
You would think it would be. You would think it would be. This was a very stable product, but it always varied. And one of the things that made it vary, it's weird. If you've ever worked with retail promotions, the manufacturer doesn't know the price the retailer is going to set at the end. What they do essentially is give them X thousands or hundreds of thousands of dollars in buy. Mm-hmm. And so that they reduce the price, but they can determine whether they use this to put it on the end of the aisle, reduce the price, so they don't know exactly what it's going to be. Mm-hmm. So there's uncertainty. It's a very strange relationship. But at the end of the day, you can think about it. I don't think I need my whiteboard for this one. Is what is the cost of shortage? What is the cost of excess? So if I'm short, right? So there's more demand for these products than I brought in my promotion. What's the consequences? Well, we're going to have stockouts, but stockouts maybe at the store, right? So if this is a brand item, maybe that means that the person's just going to go to another store and buy it at a higher margin for the manufacturer. So
how do you quantify this?
Exactly. That's my point. You hit my punchline.
Oh, sorry.
So you have cost of shortage for different things. Another cost that you don't think about is expedited transportation. So if I stock out or I'm a little low at the end of the promotion period, I've got to expedite product out there now to replenish. That's another cost. That's a cost to the manufacturer as well as the retailer. Cost of excess, if you have too much at the end of a promotion, you generally can't sell it at that same price. So actually, perversely, the retailer might make money off that. However, they might have to reimburse back to the manufacturer. Also, you have all this inventory hanging out in the store. If you've been in the back room of a store, it clogs things up. So there's also loss of efficiency and so those costs. And it disrupts future sales. You're cannibalizing future sales. So you might have to miss a replenishment cycle because you have so much extra inventory. They're going to skip the order this next week, maybe 2 weeks, and that disrupts things upstream. This is what causes the bullwhip effect in many cases. So you have these costs of shortage and excess, and two things about those in practice that happen. One, you don't know how to quantify them. They're really hard to quantify. What's the cost of a stock out? And two, as Ahmad was hinting at, they're different from the shipper and the retailer and the manufacturer. What's a cost to one is not necessarily a cost to the other, so it's not shared equally, which makes it really interesting in practice. And so the model itself is very cool, and it works really well. What gets tricky is trying to figure out those costs in practice, because no one comes to you and says, here's my cost of shortage, here's my cost of excess. It's usually a conglomeration and a best guess. And so that's what I found in practice whenever I've applied a model like this. Does that make sense?
Okay. Yeah.
Yep.
So what type of application this has? What type of project other than the example that you gave?
We've used this. So two things: students using it in their thesis projects, and then in practice. In practice, this is embedded in almost in ERP systems. It's embedded to help understand any kind of inventory decision where you're trying to figure out the replenishment policies. But in theses, we had an interesting one where we're trying to figure out, someone was doing a project with a tomato manufacturer. And the interesting thing with tomatoes is that they grow at different parts of the country at different times of the year. And so you've got to determine how much to plant at the beginning of a season, right? Can't adjust in the middle. But they've got two tracks. You can do it on the west of the Mississippi or east of the Mississippi. Just in case a storm wipes one out, you have a lower probability of wiping them both out. But the question, again, is how much to stock for that, because they had an interesting problem, because it was a double news vendor, because they had that question for how much do I plant, because the yield isn't that great, so it's almost a supply, so your probability of yield is differential. You don't want to plant too much or too little, and then your demand also is probabilistic. So they had news vendors on both ends, the supply side and the demand side. Usually, if you try hard enough, you can find a news vendor problem everywhere. It's just a matter of whenever you have uncertainty, you can find a case where you can do a trade-off. We did another one. We're looking at variability of transit in ocean transportation. And so what we wanted to figure out, because most systems that companies have, we know about lead time now, right? So the lead time for when I place an order for it to come in, it's heavily influenced by the transportation time. Unfortunately, that transportation time can be variable, right? And so what we wanted to set up was a system that allowed you for one lane to have multiple lead times with their separate distributions. Unfortunately, most standard ERP systems don't allow you to have anything more than one number for L for a pairing of a origin destination. And so what we tried to do is say, okay, when does it make sense to really even care about this? And so what we did is we did an analysis of different distributions of transit time for things coming in. It was from Rotterdam to New York for this one company, and tried to understand when did it matter? When is the volatility? And we found that it mattered on two things. One is the coefficient of variation or volatility of the transit time, right? So if it's very variable, or if it's not that variable, that's the differentiator. And the other was the critical ratio. If you had a very low critical ratio, less than 0.5, it really didn't matter to spend the extra time to come up with a more refined model. But as that critical ratio got higher, then it became you'd have an inventory savings if you really had this differentiation in a more finely grained ERP system. So long story to say how we use critical ratio essentially to capture the sense from the company of how important stocking out versus having excess was, which essentially relates right back to the news vendor.
Good. Yeah. I got a question from one of the students that about you had that new the jersey problem in the
Reebok. Great
Reebok,
case.
Yes. So what if we have
Nike owns that now. Nike owns the NFL jersey contract for their football.
What about if we have two options? We can order now, and in the other one in 16 weeks. So do you solve the problem in two different independent news vendor model, or is there any advanced combined model if you have, if you can order twice?
Yeah. So yeah, no, it's a great question, and it's something that it's covered in the literature. A lot of people look at this. It's a two-period newsboy. Mm-hmm. So essentially, what it's saying is, I have to place my initial order, but midstream I can place a corrective order.
Yes.
And so we know kind of, just think about it instinctively. You should know what this means. This means I probably will not order as much initially, right? Why? Because I can always make up later. So it would probably reduce the queue, the initial queue, and then you can catch up extra if you need to. So that queue gets reduced, so you really only have to cover up until the delivery of that new placed order. Instead of doing the whole period, right, I can now shorten that, so I don't need to order as much. You can actually, there's no closed form solution for it that I know of, but there's a lot of simulations you can do to try to say what that would mean. Because the decision point you try to do is, well, how much more can I order, right? And when can I do it? Is it a week later? Is it 16 weeks? Is it 4 months? Or what is it later? Does that make sense? So yeah, you'd solve it as one problem.
Yep.
It's a problem with two dimensions, the first and the second order. And then think of it this way, because what happens if I can order 3 times? What if I can order 4 times? And so as you start increasing this, then you start getting into a steady state replenishment standard system where you get into an SQ, continuous review, or a periodic review. So you can see from the news vendor to an RS, periodic review policy, it's just a continuum. And whether I only get to order once or I get to order every R time periods. Mm-hmm. Does that make sense? So it's really a continuum between the two systems. And the difference is what happens at the end of my period. Does the inventory go away, or can I use it for the next period? Does that make sense?
Yep. Yeah. So you already commented on how to define and estimate the penalty for stockout and salvage value. Can you also, emphasize how in practice companies define these values?
Yeah, they struggle. And so the easiest case is the one that we gave in the lecture, and that's where you know the sales price, you know the cost, and that's easy. Where it gets harder is when you're not in that pure revenue setting. And the example I gave were the contracts or the promotions, where you have these soft impacts. Truly, the cost of stock out is something that no one really has a good handle on, because there's different dimensions to it. And I think I cover this in some of the lectures. It could be that if you stock out of the product, they will never buy that product ever again in their life. And in fact, we were working with one company, and they're worried not about that so much as someone goes now onto social media and gets so upset that they influence and they start blogging about how much they hate this product because they're never there. So they affect not just their sales, they can influence a wider set. That's at one extreme, versus the other is if they stock out, I'll just wait, I'll come back. And we all have different products that we do that with. For a smartphone, most people will wait and come back. They'll back order to do it. For getting buying a certain brand of shampoo or something, we'd probably forego that retailer and go somewhere else. So there's different ranges here that each of us have, and that's very hard to quantify. There's been a lot of research there, but nothing that I've seen is consistent and uniform.
Good. Do you have any question for us?
I do.
Yeah.
So now, this is the question I want you guys to do in your breakout. And so we talked about promotions, and that's all single item. But what happens if I have 3 items that are being promoted, right? And so I have 3 items, but my budget, and so I could figure out how much to get of each, Q2, Q3, and how much that cost me. But suppose my budget is 80% of what that would cost. So
hold on.
We're holding.
Well,
Are we still there?
no, give it just 1 second. 1 sec. Right when you're 80%.
Am I back?
It's on the slide to the right. Yeah.
Okay. So I don't know where I lost you, but here's the question I want you to discuss in the breakout. We talked about having one promotion, but suppose you have 3 promotions for products 1, 2, and 3. And you can calculate using News Vendor, cost of shortage, all that good stuff, how much you should order for each and how much that would cost. And so that's the sum of the cost of product 1, 2, and 3. But suppose your budget is only 80%. So the question is, how would you allocate of how much of each to buy? Would you just reduce the quantity by 80%? Or would you do something different? So what I want you to do is discuss this, how you would treat this, and how you would approach that solution, that problem rather. 3 products, the total amount that you need to promote optimally is a certain amount, but you only have budget for 80% of that. So what do you do? Okay?
Okay. So we have the breakout rooms open, Arthur. Yeah. So the CTAs are there. Please join the breakout rooms and discuss the problem, and then come back.
See you in a minute. There's a certain